Hello, 8th graders, and welcome to lesson 9.2. This is the final lesson for this unit. Again, I told you it is very short. You only have 9.1 and 9.2. So 9.1 was all about scatter plots and getting used to how to use scatter plots and what do they really show us, okay? We're going to continue within scatter plots, but today we're going to be talking about this lines of fit, okay? So two different icons are I can find lines of fit. Sometimes people will call this your line of best fit, means the same thing, okay? Or I can use lines of fit to solve problems. So we're going to talk about what is this line of fit and how do we identify that, okay? Again, skipping the warm-up for right now. We'll just keep moving forward. Okay. Our essential question for today is how can you use data to predict an event? Now, this is actually a really good question to have given our current situation here, okay? A lot of people right now, because of the COVID-19 outbreak, are using the data that they've been given based on what's happening in China, what's happening in Italy, what's happening in Europe, to help us predict what's going to happen here in the United States. And that's why you're seeing a lot of these different governments making different decisions, different lockdown procedures, because everyone's interpreting this data just a little bit differently. Even this past week with our governor here in Minnesota, okay, he took a long time to talk through this data and to think about it, okay? So he'd mentioned in one of his meetings that he is taking the latest data to help him make some of these decisions and to help him predict how bad is it really going to be and what kind of actions does he need to take. Okay, now the questions we're going to look at today are not going to be as extreme as COVID-19, but there's a way that we can use this data to still help us predict what would happen next, okay, what would happen in years to come or so on with whatever situation we're talking about, okay? So let's go ahead and look at this first example. Again, I'm going to see if I can try and extend this here once we get going. So example 1, it says the problem shows the depth of a river X miles after a monsoon season ends. So monsoon seasons are kind of seen usually, I believe, closer to the equator. And that's where they get super rainy periods of climate. Okay, so where it rains nonstop for 30 days and it just continues to rain and it ends up flooding things. Okay. What our first direction asks us is to make a scatter plot of the data and draw a line of fit. Right now, let's just worry about creating that scatter plot. Then I'll talk you through how to make this line of fit. Okay. So it's important to understand what we are using as our X value and what we are using as our Y value, okay? So my X value is the month, okay? So this is 0 months of the monsoon. This is month 1, okay, month 2, month 3, okay? Or maybe after it ends, okay? So this is going to be the highest peak because this is the beginning. Then every single year, month afterwards, it kind of goes back, okay? Here's your depth. So what I want you to do right now I know most of you don't have graph paper. I tried to get some people some graph paper. Depends on when your teacher filled out your folders. But otherwise, just use a blank sheet of paper to create a graph, or you can use, I don't know if there's a back side of this notes that's going to work, or even just grab a lined piece of paper and create a graph. Okay, so pause the video for just a second, start setting up this graph, setting up these numbers, and I will come back here in just a second and show you how I set mine up as well. Okay. All right, so hopefully you paused the video. I created mine on a piece of paper. It's just a lot easier than trying to create this online and then showing you or creating it here on the slides. So here is my graph so far. Okay, I had mentioned that it's going to be very important to make sure you are labeling. Okay, so in this case I've got months as well. I've got my depth over here. For my X values, I went up by an increment of 1. For my Y values here, I went up by an increment of 2. Okay. It's also going to be important in these that you are labeling. okay, everything, or giving it a title. So in this time, I give this graph a title. I said depth during monsoon season. Oop, I should have said after monsoon season. I'll correct that here just a sec, okay? So here's how I set this up. If you want to pause here and kind of set yours up similar to mine, you can do that for sure. Okay. I'm going to pause the video here and start filling in then those data points. So when I return, I will have those data points in. All right, coming on back, you should have labeled everything else if you didn't finish labeling it, and then putting in your data points. Okay. So here is now, what my graph looks like, okay, given the amount of data. Looking at this graph, I can tell that it looks to be that it has a negative slope. It is very linear, and I would say this is a strong correlation because all the data points are very close together. Okay. Now, when we create a line of best fit, what I'm going to do is I'm going to basically pick 2 of these points, okay? 2 of these points, because remember, it only takes 2 points to graph a line, okay? So I'm going to pick about 2 of these points and connect them into a line that fits this as best as I can. So it's the line of fit or line of best fit. I want to try and equal it out. Okay, so maybe using that top one right here may not be the best because it's a lot higher than everything else, even when I kind of slope it down. So I'm going to create this right now. I'll tell you which kind of points I decided to use and why I decided to use those. Okay. So I'm just going to take a look at it right now. I'm going to kind of grab a ruler, or if you've got anything that's a straight edge, whether it's kind of just a piece of paper or a notebook, that works as well. And I'm going to kind of figure out where can I fit this as best as I can. All right, so here's my line of best fit, okay? For the most part, it is actually going through this point where it has 2 months, okay? And at C15, it looks to also be going through the point 5, 10, as well as pretty close to that 7, 7, and that 8, 5, okay? What I'm mostly looking for is that I can kind of figure out where these are for the most part. I want to kind of level out the amount of dots I have below the line as well as on top. Now, right now it kind of looks like I have 4 below and only these 2 on top, okay? But as long as you're getting very close to it, okay? Creating those and connecting them as you go through. All right, let's go ahead and then look at the rest of the tasks we have to do for this one. So we did this part. We made a scatter plot and we drew a line of best fit. We're good. Okay, I just did it on a separate sheet of paper. This time now it says write an equation of the line of fit. So now that I've created this line, okay, with here, I'm going to, for the most part, get as close and as accurate as I can to write an equation. Remember, think about your slope and your y-intercept. So if I'm going to look at my graph right here, let's start by figuring out my y-intercept. Okay. In this case, in the graph that I created, okay, remember where your line crosses the y, it's very close to crossing at 18. So I would say that my y-intercept is 18, okay? So that means my b value is 18. Okay, so I just wrote that over here, b equals 18. Now I'm going to take a look and see if I can figure out my slope as best as I can. Again, it's going to be a little bit of a guess. It may not be super accurate because you didn't go straight through the corners of the grid, and that's okay. So kind of looking at it, it almost looks to be that I have fairly close to a graph of a slope of 1. So this is going to be my guess, is that I have a slope of 1. Okay. Remember when we put this together with your y equals mx plus b, then that would mean that I would have y equals 1x or x plus 18. Okay. So I'll write that here as well. I would say y equals x plus 18. And it's okay if you got slightly a different slope than me. Maybe you got 1.5. Okay. As of right now, we're just trying to be as accurate as we can. It is a lot harder to eyeball it and find the line of best fit. As we continue on with this lesson, where I'm going to show you how you can find this line using a graphing calculator. And I know that most of you don't have one, and that's okay. I will show you what you can do without having a graphing calculator, a physical graphing calculator at home. Okay? Let's go to the next part, which is to interpret the slope and the y-intercept of the line of fit. Remembering going back into interpreting those. This one, I'm just going to explain it. I'm not going to write it out. It's a lot harder for me to write with this. So interpreting your slope, okay, what does your slope really mean? Okay, my slope based on the amount of here, okay, so my months to my depths. I would say that, remember, your slope is y, the change in y out of the change in x, okay? For the most part, and now, as you can see, the trend is not actually going this way exactly, but for the most part, the change in y, so the amount of feet that changes out of the change in months, seems to be about a trend of 1, okay? So it means every single month, the depth loses 1 inch. Okay, again, it's not going to be perfect because I noticed from 13 to 11, that's 2. Okay, 19 to 15 is 4. It's not as consistent as we would like. It's just a line that could represent this function, okay? And then my y-intercept, okay? My y-intercept in this case, in my original equation now, would be 20. So I could see where a lot of people might say, hey, why didn't you put 20 for b? Okay, I was going off the line that I had created. Okay, you could explain that this is 20, and you could use that in this interpretation, though. Okay, what you could explain is that when there was no months after the monsoon, so during the monsoon, the depth of the river was 20 feet. Again, if I'm interpreting this here, okay, at no months, the depth of the river was 20 feet. Okay, I could explain that the same thing with this 18. Okay. I know it's really hard to see down here. I'm going to see if I can kind of extend it here. Didn't really work very well the other day. Unless I wrote some things. Maybe I'll just make a little squiggle here and see if it works. I did. All right. So the last part on this one is predict the depth in 9 months. Okay. So this is where that prediction part comes into play that I was talking to you about. Okay. So what I can do is then when I have this, here I'm going to get myself a little bigger, is I can use my data and my line of fit to try and identify where it would be at 9 months. So using my line that I created, I'm going to figure out where does it cross to when it's 9 months, okay? Given my graph here, I would say it's going to be about 4. If you get 3, that's fine as well, okay? So I would say about 4 feet. Okay, that's my prediction. Because remember, predictions can be a little flexible in your thinking as well. Okay. Again, at any point, if you need to pause this video, take a minute to do that. If you want to write in things, feel free to email me, message me on Google Classroom, as well as talk to me during our Zoom meetings would be great as well. Okay. I'm going to keep going though. All right, so I want you to try this one here on your own. Again, I'm going to try and fix this so it's a little easier to see because it just doesn't want to extend the page. Okay, so take the time, pause this video, go through this work, okay? Set up your data, okay? They're the exact same steps we did in this last example, okay? I'm going to have to pause this video. Please make sure to look out for problem part 2. That's where I'm going to start off by going through the answers to this, okay? So take the minute, just stop this video. Don't start this video until you have finished this on your own and double check your work, and then you can come back and watch it and see if you got your answers correct, okay? See you in part 2. Bye.